Our problem was, how do we find the gradient function, or the slope of the tangent to the actual curve itself? So here is just some random curve. I want to find the slope of this line, which I've called K. It's the tangent at the point P. Now, I can estimate it with a secant. There's the one I've drawn. Now, the reason I've made it go through P is the only thing I know is the equation of the curve and the point P. So I want to include that in here. Clearly, I'm not going to get a great estimate, but let's just play with it. It's going to be an estimate, may not be fantastic. But the question is, where would I place Q to get the best possible estimate? If you imagine moving Q, imagine the green line moving. And so the answer is, if I could get Q as close as possible to P, that green line is going to get closer and closer and closer to being the same as the line K. Ideally, I'd like the gap between them to be nothing. Of course, that can't happen. But that's where the idea of limits is going to come in. If we can find the limit as it approaches, then we'll know what the slope is. So let's just blow that up a bit. So PQ, that's the line we're investigating. Now P is going to have some coordinates. Its x value is x. The y value will be whatever it is when we substitute it into the function. Then we're going to go a little bit further, some distance, let's call it h, and the y value will be whatever we get when we substitute x plus h into the function. So the slope of PQ will be this. The y values, difference between the y values over difference in the x values, and we end up with function x plus h minus function x all over h. But as I say, I want to get close as we possibly can. So we're going to try and find the limit of that slope as that distance approaches 0. That will tell me the exact answer. So the slope of the tangent, this is now our formula, will be the limit as h approaches 0 of this particular expression. If we can find that limit, then we've got our answer. That is what's known as the derivative of y with respect to x. How does y change as x changes? So we're investigating y with respect to the x values. Different symbols. Probably the most common, dy dx. And that probably comes from old notation where the d was probably originally a delta, and delta is often used in science and maths to mean change. Sometimes it's just used with a, well, I want to say an apostrophe, but I think it's what they actually call a prime. So y prime, so a dash, or another word we could use, that indicates the derivative. And using that dash notation as well, you have f dash x. So it's not the function, it's the gradient function itself. Then finally, some people say, well, no, I won't actually write down what y is, I'll put the actual equation in there. So I'm saying I'm differentiating, I don't know, x squared with respect to x. I want to investigate x squared with respect to x. But the derivative measures the rate of change. That's what a derivative is. Now we're talking about curve sketching, how the y value changes with respect to x, but we then can use it for other ideas, and it's really useful for things like motion. How is the distance changing with respect to time? Things like that. So there is our formula. It's basically the same formula as above, but I'm formalising it a bit more. Rather than saying slope of tangent, I'm saying, well, the gradient function, or the derivative, is equal to this formula. This is what we call differentiating from first principles. First principles, it doesn't just rely on calculus. It could be anything, but in maths we usually say we're going from first principles means go back to scratch, go back to the starting point. So before you found a formula, how did you get this answer? The first principle you learnt. So this is differentiating from first principles. Let's do one where we know what the answer is going to be, because it's y equals 6x plus 1. It's a straight line. We know the slope's 6. We should get the answer 6. So function x is 6x plus 1, but I need to know what function x plus h is as well. So I'll get 6x plus 6h plus 1. So my derivative, I've used the dy dx notation here, will be the limit as h approaches 0 of those things. So we get 6x plus 6h plus 1 minus 6x plus 1. But when we tidy that up, what we usually find in the vast majority of cases, this works beautifully, you will always get a common factor of h in the top, which you then can cancel. So h divided by h is 6. What's the limit of h approaches 0 of that horizontal line 6 Well, it's 6. It's 6 everywhere. We know the answer is 6. Notice the setting out. That limit stays there until I substitute it. The very last line is when I lose limit as h approaches 0, but it's on every other line before that. Well, let's try the parabola then. That was the one we were trying to do. X squared minus 5x plus 2 at the point 1, negative 2. There's my function. Function x plus h. Going to expand it out. Unfortunately, there are no like terms there, which is annoying. We just get this really long expression. So function x plus h minus function x. Anything there, you will notice on the top of the fraction that does not have an h actually cancels. And I'm left with 2xh plus h squared minus 5h. There's a common factor of h. I'm left with 2x plus h minus 5. But as h approaches 0, that h, it's got to go away. So the answer is 2x minus 5. That is our gradient function. Now, it's not the actual gradient of the curve, it's the formula that allows us to find it at a particular point. The point we want is 1, negative 2. So when I substitute in 1, I get an answer of negative 3. But here's now a really important thing. Don't be lazy. Write it down properly. Because if you just wrote equals negative 3, now we need to know, are you talking about the y value? Are you talking about the gradient function? So we need to tell it what is negative 3. Well, dy dx is negative 3, but it's only at this point. So when x equals 1, dy dx is negative 3. That tells me then the slope of the tangent at that point. I have a point, I have a slope, I can find the equation of that tangent. So let's put it in the point slope formula, and there it is. Y equals minus 3x plus 1 is our answer. 9b will do us on that one.